All right, guys, 3.6. I want to get through all of these notes today with you. You will not have homework over the weekend. Next week, Monday, Tuesday, Wednesday, we're going to review, and then you're going to have a test on Friday the 14th, your first test, okay? This first page, I call it your cheat sheet. If you use this during the test, you will be given a 0. This is not a for real cheat sheet, but this is something that you should screenshot and you should put next to every single problem we do. You are going to be asked various questions about rational functions. We'll talk about what a rational function is here in a second. One question is going to say, state the domain in vertical asymptotes. One question is going to say, what is the slant asymptote? You have to know what that is and how to find it. And this tells you that. So let's go through this together. When I talk to you guys about the domain, that's all the values that x can be. We're going to figure out what x can't be. The way that you find the domain is you set the denominator of the rational function not equal to 0. Everything in this mathematically we've done before. You have to write your answer in interval notation. Right? We're grown-ups now. We have to write negative infinity to 3, comma, that sort of a thing. Your vertical asymptote is an imaginary line, it's a boundary line, that your graph would get really, really close to but not touch. We'll talk about more of graphing it later. But to find that, you set the denominator equal to 0 and solve. So vertical asymptote and domain go hand in hand. They go together. A horizontal asymptote, that's a horizontal line that your graph gets real close to but doesn't touch. All right? Vertical asymptotes are going to be x equals. You will write your answer as x equals. Horizontal asymptotes, you write your answer as y equals. That's very important. The way that you find horizontal asymptotes is you're just going to compare the numerator degree to the denominator degree. We'll do a question like that in a second. You guys are going to be like, that's it? And I'm going to say, yes, that's it. How do you find a slant asymptote? When I say to you, okay, please find the slant asymptote if there is one, what do you use? What does it say? Long division. We all know how to do that. You write your answer in y equals mx plus b form. Your answer would be like y equals 2x minus 4. Y equals negative 3x plus 5. We have found x and y intercepts since the first day of school. X and y intercepts, to find the y-intercept, you plug in 0 for x. To find an x-intercept, what do? What does it say to do? Set the numerator equal to 0. We're going to do a lot of factoring. You have to write your intercepts as ordered pairs. Very important. We know how to do that. And then I'm going to talk about holes in a graph. A hole in a graph is where one little spot on your function doesn't exist. How do you find that? What does it say to do? You factor where? Numerator and denominator. If they have common factors on top and bottom that cross out, you set those equal to 0. Mathematically, it's super duper easy, I promise. It's just a matter of going, okay, wait, where do I look for this? Where do I look for that? So that's why we have to practice a whole bunch. Everybody with me? Okay, good job. Here we go. All right, this is what the graph of a rational function looks like. Looks like two little boomerangs. Sometimes it'll look like this, where there's something here, and then maybe here, and then over here. We're not graphing them at this point right now. What you need to know about rational functions is they have vertical and horizontal asymptotes. Those are like boundary lines. You see how I drew them like dotted? It's boundaries that your graph gets close to but doesn't touch. It's where values of the function don't exist. But a rational function is just a grown-up fraction. They're fractions. It's a polynomial divided by a polynomial. That's it. They're going to look a little intimidating, but it's nothing that you guys haven't seen before. All right, this is just a picture. Do you guys see the blue dashed line? That would be a representation of a vertical asymptote. The vertical asymptote, that blue line, blue dashed line, goes through what axis? The x. So your vertical asymptotes are at x equals something. Your horizontal, look, is the dashed blue line, and it goes through what axis? The y. right? It's only going to go through the y, so that's really important. So let's practice some of this, all right? This first question says find the vertical and horizontal asymptotes. The first thing you should do is put what? Picture of your, yep. That should go right next to your problem. So you say, okay, what do I do? So if I'm going to find the vertical asymptote, first thing I want to do, what does my cheat sheet say to do for the vertical asymptote? Set the denominator equal to 0. Does everyone agree with me that that polynomial is the denominator? It's the one on the bottom, yeah? Yes? Okay, so how do I solve this? What do I do? Factor it. That's all we're going to do. 2 times negative 2 is negative 4. What are the factors of negative 4 that multiply to give me negative 4, but add to give me 3? Say it one more time. X plus 4. God bless you. X minus 1. Does everybody agree? All right, what do I do with this little 2 out in front? I'm going to divide both factors by 2. Good job. So when I divide both factors by 2, 4 divided by 2 is nice and pretty, x plus 2. Does 1 divide by 2 nice and pretty? No, so 2 becomes my coefficient, right? So 2x minus 1 equals 0. Well, now what do I do? You set each parenthesis equal to 0 and solve it. Good. This is nothing you guys haven't seen before. I move positive 2 over. It becomes x equals negative 2. I move 1 over. It becomes 2x equals 1. Divide by 2. I get x equals what? 1/2. How many vertical asymptotes do you have? 2. Your vertical asymptotes are at x equals negative 2 and x equals 1/2. That's it. These two go hand in hand. Your domain can be any numbers in the entire world except for what? Negative 2 and 1/2. So how would you write for domain? They don't ask for this, but how would you do it? Any number in the entire world from left to right except for negative 2 and 1/2. How would you write it? Negative infinity to negative 2. Union. Okay, 1/2 is going to be over here. What's in the middle there? Negative 2, good, to 1/2. Good, no problem. So your vertical asymptotes in your domain always go hand in hand. It can be anything in the entire world. You guys have done that before, right? If we had a number line, you would tell me that negative 2 is here and 1 is here. Whoops. I said 1, wrote 0. So it could be anything in the entire world except 4. So it would be all of this, all of this, all of this. If you want to graph it real quick, just to give yourself a visual picture, it's a really good idea. But you don't have to. It should be, I don't know, I wrote union, but it shouldn't be. It should be infinity. Yeah. Sorry. All right, the other part of the question asked for horizontal asymptote. Now, this appears to be a hard question, but it's not. Look at your cheat sheet. How do you find, what does it say about horizontal asymptote? Lots of words there, right? What you're doing to find the horizontal asymptote, again, that's a y equals, you're going to compare the numerator degree to the denominator degree. So I have my numerator. This is how you guys would show me your work in your denominator. We're finding our HA, our horizontal asymptote. It's a y equals. Degree means the highest exponent of an equation. What is the degree of the numerator? 2. Agreed. What is the degree of the denominator? 2. What is the relationship between 2 and 2? Is 2 greater than, is 2 equal to, or is 2 less than 2? Equal to. Okay, here's your work. So go to your cheat sheet. And again, you will not have this on the test, so you need to know these things. What does it say if the numerator degree is equal to the denominator degree? How do you find your horizontal asymptote? It's the leading coefficient of the numerator divided by the leading coefficient of the denominator. So let's come back over here. My horizontal asymptote is going to be at y equals. What is the leading coefficient of the numerator? 3. What is the leading coefficient of the denominator? 2. That's it. 2 and 2, it's the degree. You just compare the degree of the numerator to the degree of the denominator. Let's just say I had a problem, and I'm comparing the numerator to the denominator. The degree of the numerator, the highest exponent of the numerator is 1, and the degree of the denominator is 3. What sign goes in the middle there? 1 is what then 3? Less than. So what happens when the numerator degree is less than the denominator degree? What's your horizontal asymptote? Numerator is less than denominator. Y equals 0. It's right there. What happens if I had a numerator degree of 5 and a denominator degree of 3? 5 is what then 3? Greater than. So if the numerator degree is greater than the denominator degree, what is my answer for horizontal asymptote? None. You would say none or no. That's it. Horizontal asymptote has 3 options. It's either none, y equals 0, or you take the numerator coefficient, leading coefficient, over the denominator leading coefficient. That's it. Not bad. First thing I'm going to do is get a picture of my cheat sheet, put it in there so I can just remember. Keep referring to it. Okay, I want to state the domain. Read your cheat sheet. How do you find the domain? Set the denominator equal to 0. So x squared plus x minus 2 cannot be 0. Right? You're always going to find the vertical asymptotes when you find domain, vice versa. How would I do this, guys? What do we do? You factor it. X plus 2 and x minus 1 cannot be 0. So my vertical asymptotes are at -2 and at 1. But that's not what they asked for. This would be my vertical asymptotes, but that's not what they asked for. They asked me for the domain, which the domain is just what numbers can the denominator not have in it? What can x not be? -2 and +1. So how grown up do you say the denominator x can be anything in the world except for those 2 numbers? -infinity to -2, union, -2 to 1, union, 1 to infinity. Perfect, guys. Good. That's the domain. Very good. How do you find the domain in the vertical asymptotes? You set the denominator equal to 0. I'm going to say this 100,000 times, so just get this in your brain. Now, the next 2 questions. Intercepts. First of all, how do you write intercepts? As ordered pairs, okay? So we're going to find the y-intercept. We're going to find the x-intercepts. So y-intercept would be I plug in 0. What do I get out for x, correct? What does it say? How do you find the y-intercept? Plug in 0. Okay.
You plug it in for x.
Did I say it backwards?
No, I don't know.
Yeah. No, you're right. So guys, watch. Some of you are thinking like, oh my gosh, so much work. Okay. If I plug in 0 right here, what happens?
Cancels.
Oh, it becomes 0. What happens when I plug 0 in here?
Cancels.
Oh, it becomes 0. What happens when I plug in 0 here?
0.
Oh, it becomes 0. What happens when I plug in 0 here?
0.
Oh, it becomes 0. Can everyone in here figure out what -4 divided by -2 is? It's 2. So my y-intercept, when I plug in 0 for x, I get out 2 for y. Was that super difficult? No. It's just a matter of knowing what to do. So now we look back and we're like, okay, she's trying to trick us. She's trying to make it seem like it's easy, and it's really not. How do you find the x-intercept? What does the cheat sheet tell you to do? Set the numerator equal to 0. Okay, which one's the numerator? The one where? The one on top. So it's 2x squared plus 7x minus 4. Okay. So 2x squared. Was it plus 7x? Minus 4 equals 0. Oh, jeez, this problem is so hard. Is it? No. 2 times negative 4 is negative 8. What are the factors? Hang on one sec. What are the factors of negative 8 that multiply to give you negative 8 but add to give you 7? X plus 8 and x minus 1. Agreed? What do I have to do here? Perfect. Divide both by 2. So I get x plus 4. And this becomes 2x minus 1 equals 0. All right, so now what?
X equals 0.
Equal to 0. So x equals negative 4. And x equals, when I move negative 1 over, it becomes positive. And then when I divide by 2, I get... Is that the X-Intercepts? No. Why is it not? Why is that answer not fully complete? I got to write it as what? So it's negative 4, comma, 0. 1/2, comma, 0. There's my X-intercepts, where the graph crosses the x-axis. Okay, we're good? Let's go to this one. Holes. Ay, 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 all these things we just keep doing. Holes in a graph. Well, first thing I'm going to do is look at my cheat sheet and say, how do I find the holes? What does that mean? It's just one specific point where my function doesn't exist. So how do we find the holes? What does it say to do for holes, guys? Factor the numerator and the denominator. And then what? Set the factors that cross out equal to 0. Okay, so we have x minus 3 for A. X minus 3 over x squared minus 3x. Can I factor anything more out of x minus 3 in the top? So it's x minus 3, okay? What about the bottom? Take out an x, I'm left with x minus 3. Are there any factors on the top and the bottom that are exactly the same? Yes. So we cross them out. Whatever you cross out, you set equal to 0. So x minus 3 equals 0. So I have a hole at x equals what? Positive 3. Perfect. Yep. What about B? Let's do B.
I have a question.
Yep.
So the x that you took out, you don't put it like
No, you don't have to do anything with it because all you're doing is just finding holes here.
so it's the one that you cross out.
It's the one that you cross out. Yep. So I have x cubed minus 2x squared over x minus 2, yeah? Okay. Can I factor anything out of the top? What? Perfect. I'm left with x minus 2. What about the bottom? Leave it as is. Good. Do you guys notice anything? What? They're both the same. So we cross it out and we say, okay, there is a hole there. So I have a hole at x equals what? Positive 2. Perfect.
You can't just say, hole at 2.
No, x equals. Good question. It's going to be super duper important for you guys to have x equals and y equals. Because there's different values on different axes. So if you had a question like this, say you factored it and you came out like this. And I said to you, where are the holes? Are there any factors that are exactly the same on the top and bottom? You would say there's no holes. They have to be exactly the same. Not close, not almost. They have to be exactly the same. What about if you had like x minus 1 over x minus 1, x plus 1? Do you have a factor that on top and the bottom that's exactly the same? Yes. So you'd have a hole at what? X equals 1. Both of the x minus 1s don't cancel out. It's got to be 1 on top. That's exactly the same as the one on the bottom.
X doesn't equal -1 either? Or it's just
Whatever they have in common, that's okay. Whatever they have in common, cross out, set equal to 0. So mathematically, is there anything here that you guys have never seen before? No. It's just a matter of knowing, okay, this question says, how do I find x and y intercepts? Or what are my x and y intercepts? The question was, can holes be imaginary? You're talking only about real things because we're graphing it on a real XY coordinate. So you won't have imaginaries on this stuff. Anything else? Okay, so what we're going to do right now is called the slant asymptote. Now again, we talked about vertical ones. Vertical asymptotes are up and down, right? Horizontals are left and right. So a slant is what kind of a line do you think? A slanted line. That's it. Now you guys are like, oh my gosh. Again, we're not graphing these right now. We're just algebraically finding everything. So how do I find the slant asymptote? What does your cheat sheet say? Use long division. We've done this before. Long division. This problem says x squared minus 4x minus 5 divided by x minus 3. That means x minus 3 goes on the outside, and x squared minus 4x minus 5 is on the inside. How do we do long division? We say first term into first term. X times what gives me x squared? X. Perfect. So I write my x. Remember, get your subtraction set up before you go ahead and multiply. Now when we multiply, x times x is x squared, and x times negative 3 is negative 3x. Agreed? Before I subtract, what do? I got to distribute. I'm going to change. So I have negative 4x plus 3x gives me negative x, right? Bring down my negative 5, and then we do the whole thing all over again. I say first term into first term. So x times what gives me negative x? Negative 1. Get your subtraction ready before you do your, get it all set up before you multiply. So negative 1 times x is negative x. Negative 1 times negative 3 is plus 3. Good. And before we subtract, we distribute. What is negative 5 minus 3? Negative 8. What is negative 8 in this case? It's my remainder, okay? What I want you guys to understand and to realize, how do they want this question answered? Y equals mx plus b. Right here is your y equals mx plus b. The remainder does not matter. It is not included in your answer. So you guys would tell me your slant asymptote is at y equals x minus 1. It's just a slanted line like that. But you do not include the remainder. You do long division like normal. You do not include the remainder. So the next page you guys have are 3 examples. You do not have to do them for homework. I'm going to do them with you on Monday in class, and then we're just going to practice and practice and practice. If you want to try, see if you can do it, figure it out, compare your answers with what we do on Monday, that's perfectly fine. But we're going to just practice this Monday, Tuesday, and Wednesday. We're going to review on Thursday and take our tests over 3, 4, 3, 5, 3, 6 on Friday the 14th. We good? Thank you guys so much.